Yo, what's going on, guys? Welcome back to day 9 of the advent of cyber. So today we are actually doing malware analysis. This is something a lot of people ask me to do all the time on my channel. And I will tell you the reason I don't do it very often on my channel is because I am not an expert in malware analysis. I can analyze malware and I do analyze malware, but I'm not an expert. There are people that do this every day, all day. That's not what I do all day, every day. So it's not something I want to teach and have bad habits or anything like that I'm teaching people. So that is why I don't do it very often. Now, with this box, they guide you on it and I can easily talk about it and tell you what's going on. So let's go ahead and hop into it. I just wanted to put that disclaimer out there for people that want to keep seeing malware analysis on my channel. So let's go ahead and hop into it. Hit that like, hit that sub button if you guys like the content. Now let's get into it. The first thing we're going to do is we're going to be using DNSPy, which is a .NET framework tool that it decompiles C# and can also compile and write and all that stuff. So you can see we're here. I'm not going to walk through everything they do because you can see they actually have where you can view different code snippets and keep diving deeper into it if you want. We're just going to do what's needed for the box so that we can get day 9 going, okay? So first things first, this actually continues day 8. So this is the same machine that you stood up for day 8. The only difference is now we have the malware that if you tried on day 8, it was actually password encrypted and you had to have a password to open the file. Well, now we have it. So we just go to desktop, maybe, there we go, artifacts, and we just change this to all, and we open this up. Now this is a defanged one. If you don't know what defang means, it just means that you can't go to the URLs, that it's not going to actually run, okay? So you can see that by defang they mean like the main function is commented out. So that's what they mean by main. It's not going to run, it's not going to go anywhere, it's not going to do anything, okay? So we go ahead and hit the program main because that's what we're trying to look at, right? If you know how a program works, the main function's called and it does those steps. So we do main, and I'm going to skip down to the questions because you can read this if you want, and it's explaining kind of more in depth. But if you don't know how to code at all, you're just going to get lost in that conversation anyway. So if you're not familiar with coding or even coding best practices, things like that, maybe go back and learn a little coding and stuff, then read what they're saying, because otherwise you're going to get lost in it. That's something I think they have a tough time with, TryHackMe specifically, is when they get into complex concepts, they kind of, if you don't know what's going on, they just throw it at you and you hope for the best. So let's go ahead and hop into it. So the first thing here, it says what HTTP user agent was used by the malware for its connection to request to the C2 server. Well, first thing I'm going to do is I'm going to hit this drop down menu, okay? Because I want to see all of the modules and all the functions. So what we're going to do is we're going to just kind of see what's going on. So if we follow the main function, and this is what they talk about, you can see, okay, so it's got a sleeper count, and then the count up here is 15 seconds because it's 15,000 milliseconds. So it sleeps for 15 seconds, it looks like, and then it's going to reach out. Now they do have a decryptor, so it is encrypting it, and it looks like, okay, here we go. If it's not asleep, so if it's not the sleep function, then it's going to drop into a shell. Okay, if it's not the shell function, it's going to drop into the implant, and if it's not the implant, it's going to quit. Okay, so it looks pretty obvious. They're going to go in, they're going to implant, which is going to probably run another piece of malware. Yeah, right here. It's going to run this, download and run this malware, spykit.exe. Once that implant's ran, it's then going to drop into a shell, and then it's going to sleep for 15 seconds. Okay, cool. Easy enough. So we're going to hop into it and we're going to kind of look. So the first thing they're asking is pretty simple. What is the user agent? So if you don't know, whenever you connect to something, any machine with using HTTP or HTTPS, it needs a user agent. So your packet has an actual user agent, and that user agent will tell the system what you are. Are you Firefox? Are you Chrome? Are you what? And the reason for that is because different websites render differently in different browsers, so it needs to know. The other thing to keep in mind is these come into play when you're talking about sessions. So let's say you have a session and you have a cookie identifier, blah, 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 and you're saying I'm user 1. Well, that website might track, well, you're user 1 and you're logged in on Mozilla Firefox and your IP address is XYZ. That's how your session's stored. So then if you tried to open an incognito window and use the same session cookie, it may not work because it may say, okay, well, you're from a different place now. So it uses multiple different things, but that's why a lot of times you'll see this used as a user agent that people put in because it's a common one. So let's go ahead and see if we can find that. So what HTTP user agent was used by the malware for its connection? Well, let's look at the implant first and just see if it says it in the implant. Okay, it doesn't look like I see it in the implant. That's just getting the URL. Okay, so the post it, so it's running a post request. There we go. Look at that, user agent. So when it's calling back to the web server that is the C2 server, it's using a post request. And the reason it's using a post request is because it can put data in the body of the parameter. Most likely that's why. I don't want to say that's why because I didn't write this malware, but most likely they're doing it in the post request because then it's in the body. It's not in the get request where it's in the actual header. So it's a little less easy to find or to alert on. So what is the HTTP method used to submit the command execution? We just said that, post. It says it right here, method, post. What key is used, and hopefully you guys can see this. I know it's kind of, let's see if we can make it a little bit bigger here. Let's see, is there, even though I'm having a tough time viewing it. Let's see if we can get, I cannot make it bigger. I'm sure there's a way, I'm not familiar with it. So I'm sure there's a way to make it bigger. Let's see if we can zoom down here and just make it 200 times. That might be too big, but we'll see. Okay, that's not too big, I don't think. Now we'll move my camera because my camera is probably right in your way. Okay, so you can see, to go back through what we did, here is the actual user agent. Okay, and all we did is we went down here to the post it part of the program because we know that it's going to be a post request. And then here it's saying the HTTP web request method is post. So pretty easy. Now, what key is used by the malware to encrypt or decrypt the C2 data? Well, let's just think about it, right? If we're going to decrypt or encrypt, let's just go to the decryptor or the encryptor function. So let's look. Okay, and right there, you can't hack this super secure 2 keys. C2 keys. Okay, pretty easy. Can't hack it. Now, keep in mind when this is running, it may be hidden, but when we're actually compiling this or decompiling the malware, it's not hidden, right? It's in plain text there. So now, what is the first HTTP URL used by the malware? Well, let's go to the program. Let's go to the main again. All right, and let's take a look. So right off the bat, we see that it's McCready secret c2.thm, but you can see its URL equals string plus /reg or reg. So that's the first one being used, okay? Now, how many seconds is the hard-coded value? Well, we already talked about this one. 15,000 milliseconds, which is 15 seconds. So pretty easy. So that's, you can tell it's there because it says an integer count 15,000. They're setting that variable, and then down here it's saying program.sleeper count. So it's going to sleep for 15 milliseconds or 15 seconds. I'm sorry, 15,000 milliseconds. What is the C2 command the attacker uses to execute? So this one you might have a little trouble with understanding, but I'm going to break it down. So this one you can see here if you follow what the main function is doing here, and hopefully you guys can see it. Let me get my camera actually over here. I apologize. So we'll go ahead and look at it. So here, as we're scrolling down, we're looking at what it's doing. We've got the sleeper. That's great. And I am scrolling. It's just a very, very slow thing. So here's the thing. If it's not the sleeper, okay, now we've got stuff popping up. If it's not the sleeper, then it's shell. So if it's shell, we drop down. Maybe. All right, and you can see if the box wants to cooperate here. Okay, if it's shell, then the program.encryptor execute command. So then it's going to execute the command. So the C2 command they're using is the shell. Okay, and then what is the domain used by malware to download another binary? So this is another binary. Well, that's right here. And the reason is because if it's not the shell, then it's implant. Okay? And that this is the implant right here, is the spykit.exe. So it's stash.mcgreedy.thm. If that doesn't make sense, it's going to check if that stash or that spykit.exe is downloaded. If it is not, then it's going to say, go ahead and download this. That's the actual payload. Okay, that's the actual attack or exe executable that's dangerous. This is more of a dropper. If you've ever heard of a dropper, it will actually take it, put it on a machine. It will reach out and try and get the actual payload. Okay. Now, oh, that was the last question. Okay, check out the malware analysis module. So this one, I think they do a decent job. You know, it's okay. I think they threw this one at people who, if they don't understand coding, they're not going to understand what's going on, and it's not their fault. So I think if you really have no idea what's happening here, then go ahead and start learning a little bit of coding. You don't have to be an expert. You don't have to be able to write this program or anything like that. But this is a very simple program that even without coding experience, if you break it down and go through these modules just one at a time, there's not very many, you could probably figure out what's going on. So I recommend you do that. Go through program, then go through decryptor, encryptor, execute command, and kind of follow the process of what's happening, because it's a pretty simple program that is downloading an executable, running that executable, then it's prompting for basically to run C2 commands, and then it's also calling back and sleeping every 15 minutes. So it's a pretty cool little program, but it's the malware we found from day 8. So I don't know if this is going to follow us day 10, 11, 12. I have no idea. But hopefully you guys like this. Hopefully you guys are enjoying the content. And if you are, hit that like button, hit that sub button, and thank you guys. Have a great day.